about balanced and unbalanced forces. So in your notebook, what I want you to do is split your notebook all the way in half down the middle, your page that you're working on, inside your forces and motion section in your binder. And on one side, I want you to write balanced forces. On the other side, I want you to write unbalanced. So over here is unbalanced forces. Remember that a force is a push or a pull. And sometimes when a force acts on something, you kind of see it happening or you don't see it happening. So let's talk about a balanced force. A balanced force, when you see forces acting on something and the forces are balanced, the object may be at rest or it might not be moving. An equal amount of forces is acting on the object in opposite directions. For unbalanced forces, the object may be in motion. It may be moving. If I push a chair that has wheels on it, the chair is going to move. I push the chair, it'll move. And a balanced force will have an unequal amount of forces acting on an object in opposite directions. Some picture examples too. So, okay, to describe forces, we can draw pictures and they will have arrows on them. So here's an example of a picture just like this. We have a dog who is sleeping, and if a dog is sleeping, unless he's wagging his tail in his dream, usually the dog's not moving. He's not changing his location. He's not in motion. If we look, his heart is pumping inside of his body, but when we say he's at rest, he's not moving, he's not changing his location. He's not getting up and walking to a new spot unless he's sleepwalking. But this dog is not moving. He's sleeping on the floor. If we look at the force arrows that are drawn all over this dog, the arrows are describing the forces acting on the dog, okay? So if you look here, the floor is pushing back up on the dog, and it says 5N. Remember N? What happened there? N means newtons. And it's how we measure forces. We measure length with centimeters, we measure time in hours, we measure force in newtons. So acting up on the dog is 5 centimeters, 5 newtons. Acting down on him, probably gravity, is 5 newtons also. This is the same as this, okay? The forces acting in opposite directions are the same amount or magnitude. Magnitude means amount, essentially. It's an O there. Magnitude. So if they say an earthquake had a magnitude of 7.5 on the Richter scale, that's the amount of shaking that went on. If we look at the other arrows that were drawn here, it's 1 newton, and in the opposite direction, it's also 1 newton. Okay? So let me erase to make this a little neater. The opposite direction forces are equal. So is this dog, is the forces acting on this dog balanced or unbalanced? Right, so we would place this dog, we can move him around on my screen here, we can place him in the balanced column. He has balanced forces acting on him. Question about, do I draw this in my notebook? You're going to get picture examples just like this in a second, so you don't have to draw this one right now. Okay, if you already drew it, great, you have an example already. Here's another picture, and this is an apple. You see force arrows drawn. There's 50, whoa, here we go. There's 50 newtons here acting down. Okay, that's probably gravity, pulling it down to the ground. Then we have 10 newtons acting back up on it. We can probably describe the apple's motion. What do you think is happening to the apple? What's happening to the apple? It's falling down, right? Maybe it's falling out of a tree. Gravity is acting stronger than whatever's pushing back up on it. Maybe air resistance. Okay? If you drop a piece of paper, it kind of goes in this direction, and then it falls to the ground. I want you guys to notice that this arrow is a lot bigger than this arrow. Okay? What's that mean? When the arrow is bigger, usually the force is a lot stronger. That's a good question. So, 50 newtons acting down, 10 newtons acting up. Is this balanced or unbalanced? Unbalanced. So yeah, we're going to go ahead and keep this apple in this category. I'm going to make this drawing a little smaller. Smaller. And there's a reason for that. What I want you guys to do, you have a big T-chart here. In your notebook, I want you to make even smaller T-charts in your columns like this. Even smaller T-charts inside your column. Go ahead and do that right now. And on the T-charts, I want you to write picture, evidence. Picture, evidence. So what you guys are going to get is a sheet of pictures. Let me explain. You're going to get a sheet of pictures. So you're seeing my camera, my dock camera of my desk. You're going to get a sheet of pictures, and you're going to cut out all of them. So let's cut out this kid hanging out and playing video games. And once you cut them out, you're going to decide, let's move these to the side. You're going to decide, okay, is this balanced or unbalanced? This one in particular, 2 newtons acting down, 2 newtons acting up. We hear it's, which? Balance. My kids are telling me it's balanced. So we're going to put this in the balance column. And then you are going to write evidence. What told you it belonged in the balance column? I want you to write evidence right here. Once you're done, draw a line, go back, and pick out the next picture. You need to be doing all 8 of the pictures that you get on your paper. There's glue sticks and scissors in your team tubs on your desk.